Given f of x is equals to 2x squared minus x, determine the prime of f of x from the first principle. If you take a look at your answer sheet, you will see that they did this in two ways, but both ways are the same. The only difference is where they choose to simplify the top part, right? So by the top part, I mean, we know that the prime of f of x, or the derivative of f of x with regards to the first principle, we have an equation that says the limit as h approaches 0 of f of x plus h minus f of x over h. They are the same. The only difference is that the first part, the first method, chooses to simplify this method outside of the limit part. Reason being is that if you choose to do it inside the limit part, you must continuously write the limit as h approaches 0, the limit as h approaches 0, which can lead you to make mistakes. So I would recommend going with the first one, where you go outside and you first figure out what is f of x plus h. So f of x plus h, all that it means is where you see an x, because it used to be f of x. Wherever you see an x, it's no longer just x, it's going to be x plus h. So let's see how that looks. X plus h squared minus x plus h. Let's go ahead and expand on this. We'll get x squared plus 2xh plus h squared, and we get minus x minus h. And let's multiply out with the 2x squared plus 4xh plus 2h squared minus h and minus x. Let's now consider this equation minus that equation. So we get 2x squared plus 4xh plus 2h squared minus x minus h. Then we're going to go ahead and minus that part, which is 2x squared minus x, which will give us a positive x. Then we look for like terms. So 2x squared and minus 2x squared are like terms. If we sum them up together, they give us 0. So those two cancel out. Then we get 2 minus x and plus x. Those are like terms. If we sum them up together, they will then give us 0. There are no more like terms, so we are left with 4xh plus 2h squared minus h. Then we can go ahead and substitute it into our limit equation. So you will have to continuously write limit if you choose not to do this on the outside. xh plus 2h squared minus h is equals to, over h. Okay, then we'll take out h as a common factor. As I said, we must continuously write the limit as h approaches 0. So we have h is f of x plus h okay, that is actually 2h minus 1 and everything over h. These two h's will go ahead and cancel each other out. Then we only have the limit as h approaches 0 of f of x plus 2h minus 1. Now we understand that it is when h approaches 0. It's not necessarily h is equal to 0, but we will substitute in h is equal to 0 to actually see what happens to our equation when h approaches 0. And we get that f of f4x minus 1. So the derivative is 4x minus 1.